Welcome, I'm Simon. I'm one of the Lucene Solr committers. I'm one of the people who actually write that code, all you people using. I'm happy to be here. It's a fantastic conference, so many people coming here, and there's actually so many people here in that room who want to know about that little stuff we're doing in Lucene, right? There's so many Solr talks and so many high-level things. I'm actually happy that so many people made it to the rather low-level thingies. About me, I'm a PMC member and a Lucene committer. I work for a J-Team as a contractor. I'm a freelancer, so most of the time I spend working with J-Team, and they actually ask me to do work on Lucene. So most of my time I spend on doing stuff on Lucene. And today I'm going to talk about DocValues. DocValues has another name. It's also called column stride fields, and it might even have a third name eventually until we sorted it out, because there's some naming conflicts. There's already a DocValues class in Lucene. So for now, if I'm talking about DocValues today, it's going to be a new feature, right? It's nothing to do with function queries. All right, so my first slide is about Berlin buzzwords. The reason why I'm putting this slide up is I'm one of the organizers of the conference, and if somebody is from Europe or wants to do a trip to Europe in 2 weeks, it's going to be a super cool conference. We did it last time, the first time last year, and there were about like 400 people there. It was a good crowd, a lot of committers, all those kinds of projects. It's mainly based on 3 topics: search, store, and scaling. The scaling part is like spread all over the parts, but for search it's mainly Lucene, Solr. There's also Elasticsearch talks this year, and the store part is all based on NoSQL. So there's a lot of cool people coming. There's people coming from Facebook and Yahoo, and Duck Cutting is giving the keynote. So if you're interested, I'll be happy to welcome you there. There's also flyers out at the Lucid booth. There's a discount code on it, so if you want to get a ticket, you get it from there. So what is this all about? Actually, it is solving a problem which has been standing out for a long time. There's a lot of workarounds for a problem we need to solve here, but let me first introduce you to what we're actually talking about. So Lucene is basically a reverse index, right? You use your terms to look them up quickly. You find all the documents where the term occurs in, right? So you take your documents, put it in a reverse index. It's basically a sorted list of terms. They're all unique. And dependent to that term is a list of documents. You do a search, and basically what happens underneath is, what has been happening until 3.0, is doing a binary search on that sorted dictionary, and then we just reverse the posting list. All right, so once you got the posting list, you got an AND query. You want to like do the intersection or do a union or do whatever you want with those posting lists, and then you calculate the score, right? Once you calculate that score, well, there's like TF, IDF values going into that score. But a lot of people have needs to put additional values into it, like click feedbacks or like page rank. Especially page rank is kind of interesting because it changes over time. Click feedback changes too. Some values you want to put into that are constant for the most of the documents, but in a lot of use cases, those values change frequently. All right, currently we have 2 different ways to get data out of Lucene. One is field cache, right? How many people use field cache? Oh, there's tons, right? Yeah. The other one is stored fields. But you're doing like a big OR query, and there's tons of documents you need to score. A stored field to retrieve for every document is just gonna take ages. It's also not what it was made for, right? It was made for getting like a whole bunch of values of a whole bunch of stored fields for like result rendering or highlighting or anything like that. Well, There's the other way, the inverted index, but the inverted index only maps terms to documents. So that's why we have to use field cache, right? How that works, I'll explain later. But there's no fast way or native fast way to retrieve values per document. So there's a couple of reasons why we shouldn't use stored fields. Well, for the most important reason, it's really, really slow if you do it for tons of documents. It's fine when you want to render like the top 10 or the top 20 or whatever. You just get them and run them out to your XML response writer or whatever you have. But for like billions or millions of documents, a big OR query, it's just gonna slow down your search a lot. I don't have any numbers, but it's like we're talking about a couple of seconds, right? At least. How does stored fields work and why is it actually slow? Well, it's all stored on disk, right? There's nothing in memory. Well, there's a couple of things are in the file system cache, but what you have to do for each document is you have to go through the file index file and get the absolute pointer for the document and then go to the FDT file and actually scan through until you get the field you wanna retrieve, right? So it's like for every document, you do 2 seeks. Well, so the average time with a seek depends like between 5 and 10 milliseconds. So you can easily calculate how long that takes. There's another slide which visualizes this. So it first goes and looks up the absolute value and then repositions into another file. The other faster way is to use field cache. So a field cache, I just call it wait here. The field cache is just a document ID to value mapping, right? It's basically an array. And when you do search, you get a document ID when you score, and then you just look it up and calculate your score from out of that. But how is that created, right? Since we only have stored fields, loading stored fields takes a lot of time. It's actually created from a term index, right? You index your terms, and they're all like unique, and they have the posting list attached to it. When you load your index reader and you load your field cache, so the Lucene goes through the whole entire term dictionary in sorted order and selects all the document IDs and fills the values up into field cache. Until 4.0, Lucene is using strings on the term dictionary level. So you also have to parse the string, right? So it's the string represents 2.7. You have to parse it and get the 2.7 out of it. Float parsing is not easy. It's not cheap. Yeah. And in Lucene 4, that's why I put bytes under here. It's a little easier. You could encode it differently. You could encode it as a try field, and then you don't have to parse a string. You only have to convert a try field. Or you could do your own float encoding. Need to specify the sort order and those kind of things. Anyway, if you have a big index, right, loading that up takes a lot of time. If you have a lot of unique values, which could easily happen if you have like arbitrary floats, this can take multiple seconds or tenths of seconds. So, well, once it's up in memory, it's pretty fast. It's basically constant time lookup for every document. But loading it up can take a lot of time, right? So that's one downside, especially when you do real-time search. You rely on loading your index pretty quickly. The other thing is that Lucene 4 has pretty neat loading times for term dictionaries. I have seen benchmarks, the latest I've seen from the HathiTrust index, it's about like 40 times faster than in Lucene 3. So you want to take advantage of this, right? And you don't want to wait until your field cache is filled up when you open your reader. So to give you an impression how long it takes to load like 100,000 documents, 120 milliseconds, not that slow, right? But that's only for one field, right? A lot of people do use field cache in multiple fields. Maybe you have like 5 or 10 full fields. That adds up, right? And 10 million documents. How many people have more documents than 10 million? Okay, right? So It's like 3 milliseconds. That's an optimized index. So if you have multiple segments in the index, it's even taken longer than that. I have to say this is parsing the string, so that's the worst case, right? Well, once it's up in field cache, it's super fast, but it's still kind of a workaround to load or un-invert the field into memory. The real question is, what happens if you don't have enough RAM, right? Not a lot of people have those problems, but it actually depends what kind of use case you are serving here. I used the scoring use case as an example, but there's more about that. There's also, imagine a distributed search, right? And Solr distributed search works is it's basically doing 2 round trips, right? It's selecting doc IDs on the first go, and then it actually selects the actual results on the second go. When you get the Solr IDs, it's basically getting it from a stored field. Or you could get it from a stored field. So it's like you get 10 documents from each shard, 10 times loading a stored field is 20 seeks per load. Then you have to rely on that the stored fields are written in sorted order or in the right order so that the ID is at the beginning to have the optimal performance. That is not ideal, right? Especially for a field like the ID, you probably just want to do one seek, got to look up and return the value. Another problem I personally have having is if you only have like 2 megabytes of heap space, like on an Android phone, loading field cache is impossible, right? There's just not enough space. It'll just kill the application immediately. With another index, like doing 100 million documents, you don't want to wait like 30 seconds until the index read is open. It's all worst case, but still, I use it to explain the use case. Lucene is basically missing a native data structure for this. And this has been around for a long time. I'm not sure when the first time was raised, but it was like a couple of years ago. All right, the more native solution to this is what we call column stride fields or DocValues. I'm going to use DocValues for the rest of my presentation. So we're actually talking about having another name. Oh well. What is DocValues? It's basically a dense storage per document, right? So you have a certain value for a field. You want to store that per document. Lucene will basically give you the opportunity to build kind of a spreadsheet. You just have columns. That's where the column stride field name came from. And for each row corresponds to a document in your segment. And based on what you want to store in that field, you just put a type-safe value in it. It supports all the Java primitives like integer, long, float 32, float 64, well, double, and byte arrays, right? So you can basically put in whatever you want. That doesn't mean that you cannot index the field anymore. It's completely optional. It's just another option to storing it or indexing it. You can just say, okay, instead of storing it, I just want to put it in column stride. The only limitation here is that you cannot use multi-values. You have to have one value, right? So multi-value fields won't work with this right now, but I think that's going to stay. So how does this look like? It's pretty simple, very straightforward. You have a couple of fields. You specify what kind of type you have, int 64, int 32, float 32, and you just put the values in, right? And the index of the row is the document ID. You could basically do that without this feature inside Lucene. You just have to make sure you're deleting the right columns and you reference into an auxiliary storage. But it's kind of a hassle since it's not fully integrated. It doesn't do segment merges if you do an auxiliary storage. The DocValues feature is entirely integrated. So it will merge it remove deleted documents, it will merge the values together, it tries to compress them as it can. But it still leaves a lot to the developer. For integers, we currently have only one implementation. It uses a compressed scheme, which depends on the highest value you're indexing. It's pretty simple implementation. It'll be normalized to 0, and then it takes the biggest value, and that how many bits you need first to store that value. Those many bits will be used for storing each integer. There's one limitation here that we cannot address negative values yet, but there'll be a second implementation, which is actually already in my working copy, but not in trunk yet. For the byte case, there's way more options, but well, that's the good news, a lot of options. The bad news is you have to decide yourself. We are thinking about being a little smarter about picking what kind of implementation we could use for certain fields, but it really depends on the use case. Let's say you have a byte value which is fixed for every document. You probably just want to do a fixed straight implementation, use the fixed straight implementation which writes a fixed amount of bytes for every document, even if you're not specifying it, right? If you have fixed values for every document, but there are a lot of duplicates in, you might want to do the fixed deref solution. It really depends on what you want to do with it. There's one variant I don't have on here. It's the deref sorted. You can also do the sorting while you're indexing, and then you can do like an ORT lookup or give it a certain byte sequence and you get the ORT back. That is kind of useful for sorting, basically. So you do the most of the work while you're indexing. With DocValues compared to the field cache, you have two options. You can load it into RAM entirely, right? And then it's basically an array, or depending on what kind of byte version you use, it uses two-level storages, looking up document IDs to in-memory pointers. And the other option is a sequential on-disk access, right? It's basically it's very similar to stored fields, except that it doesn't do the indirection. So basically, you have one seek for certain types. If you have a deref type, I just showed here, well, then you have to do the indirection, right? But it always depends on the use case. If you can afford it, it's fine. For the on-disk sequential access, you can also specify that you want to load that file into a memory map buffer and read it from the buffer directly. So you can define like one field which should always be in memory, or the operating system should try to keep in memory as good as possible. But that on a per field basis. With stored fields, you can't do that because stored fields are all stored together, right? So you cannot say, okay, this field's more important than the other one. With column-stride fields, that is actually possible. There's one downside to this. Since we can select a certain type per field, we also have to write an entire file per field. If you have a lot of different fields and a lot of different types, you're going to end up with a lot of files in your index, and you'll get problems with the too many open files. There are going to be solutions that for instance, we're using compound file systems only for the column-stride fields and only for selected column-stride fields. But this has not been implemented yet, so that's one big limitation. But if you don't do like hundreds of column-stride fields, you probably should be fine. I put the almost here because there's one Iterator API which uses a little bit of memory to actually do a sorted traversal. So if you use the byte sorted version, that needs to load the index in memory, otherwise we're going to jump back and forth. So how does the API look like? It's for adding column-stride fields to a document or a field. It's pretty simple. There's a dedicated field, it's called DocValues field, where you can just put a float or a long or an integer byte array into that field, put it in a document and index it. If you need to store it or need to index the actual value, you can also add that to an existing field. So you just take the DocValues field and set it to the field. This one new thing a couple of people won't have seen before is bytes ref. I should actually ask Grant, how do you explain this in trainings? You didn't. Bytes ref is the replacement for string in Lucene 4. Since Lucene 4 is operating on bytes instead of strings, and to make it simpler, let's say it's UDF-8 bytes. We have to have a representation. We just don't want to use like byte arrays passing in. We introduced this bytes ref, which actually defines a slice of a byte array. The bytes ref holds an entire byte array and offset on a length, right? So the value it's representing is defined by the offset and the length. If you don't interact with Lucene directly, you won't be touching this at all. I just want to make it clear to people, if you're going to look at this or try this example or anything, don't worry, bytes ref all over the place. It's the new important class. For reading, we have two APIs. One is the Iterator based, and one is an entirely in-memory one. Here we're just looking at the DocValues enum. It's very, very simple. It's almost the same structure as a scorer or a filter is using. It's based on docID set iterator, and what you can do is you can just jump to a document, right, with using advanced, and then like linearly scan to the next document having a value for this field until there's no more documents. This is the pattern which is used all over the place in Lucene. If you look into like solar implementations using scorers or filters, that's the pattern they're using too. So it's consistent, that's the good news. To reference or to get the actual values out of it, you have to have a reference to the actual values. It's similar to the bytes ref. We also have a floats ref and a ints ref. In this example, that example actually relies on that the value is always at offset 0 and it's only one value. But there could be implementations that expose the entire array, right, into your floats reference. And when you call like advance, it just changes the offset, right? So it's been made for future optimizations, and that you don't have to have a second method call to get your actual value. The RAM resident API is currently called source, which is a very, very generic name, and we're still thinking about different names that it might change until Lucene 4 is released, but we're gonna fix the name until there, so we're not gonna change it later. For the source, it's pretty straightforward. It's just gonna call get float or get int or get bytes with the document ID you want to get, and it gets back a type-safe value. And it's not parsing anything, right? So that's also how they represent it in memory. If you decide you don't want to use the disk-based API, or you don't want to read it directly from disk, but you have it already in memory, but your code is using the iterator, you can also get an iterator from the actual in-memory representation. Well, can you add your own implementation? Yes. It's kind of a shame, actually, that my talk is today and Uwe's talk is tomorrow, because it would be nice if you would know about flexible indexing. This is already integrated into flexible indexing. And I don't want to talk too much about it, because Uwe is going to give a really good presentation tomorrow, I'm pretty sure. But let me quickly introduce you to how this is extendable. In the past, Lucene was kind of a black box underneath index writer, right? And underneath index writer, the same applied. But in Lucene 4, there's another layer between index writer and index reader and the directory, right? It's called the codec layer. And the codec layer takes care of how to encode those values. For DocValues, it would probably get an array of integers, and how these integers are written to disk, it's up to that codec. Yeah, so the codec is just in between the directory, index reader and index writer, and the flex API sits on top of it, right? Once you write DocValues, index writer will pull one of those DocValues consumers, and this is the point where Lucene gives up the control and let the user decide how to write this on disk, right? So, for instance, if you have you want to use 1 bit and you index bytes for DocValues, you can just make sure, okay, I'm not using the entire byte for every array element, but I just want to you just use 1 bit. You can basically do that. Well, if you have a writer part, you also need a reader part. That reader part is the DocValues producer, and that you get from the Flex API and the codec. And this is how you can extend or change the implementation in those low-level APIs. All right, those are the exact same benchmark as we have seen before. Field cache versus DocValues. It's actually reasonably fast in comparison to field cache. So 90 milliseconds to load 10 million documents is slower than I would have expected, but the thing is that we still have to convert an integer to a float. So this benchmark is based on floats. If you have certain binary implementations or you highly specialize something, it might be even faster. So you don't have to reinterpret your bytes here. Actually, the 100% faster is wrong here. 100 times faster because my previous benchmark had a problem, and I obviously didn't update that one. If you wonder if the actual field cache versus DocValues success is slower or faster, what I did is I used a custom score query, and I indexed a couple of DocValues fields and a couple of fields which get turned into field cache, and run all kinds of different queries we use for benchmarking, wrapped with this custom score query to figure out if it's like much faster, much slower. But the results are basically in the noise, so it doesn't make a big difference. It actually makes a difference depending on how many implementations you have and how your JIT compiler inlines this stuff. But I try to stay away from this for here, so just a plain implementation. There's no big performance impact if you use DocValues versus the field cache. All right, so the current state of DocValues is that it's still in the branch. We're currently working on landing it on trunk. So when I wrote up the proposal for this talk, I was actually pretty sure that it's going to be in trunk until today. That didn't work out. I got a little bit distracted by other features like document writer per thread. I think Jan will a little bit talk about this. But I expect to land it within the next 4 weeks. There's a couple of Javadoc issues and 1 or 2 tests would need to be fixed, but yeah, that's about it. Well, current features. It's fully integrated into codecs. It's basically comparable. So we met actually the targets we were having to be not super much slower than field cache and have a faster loading times. And the nice thing about it is that you also can access it on disk. So if you have restrictions to that and you don't want to load up your entire document IDs into memory, that's something which can give you definitely a different alternative. But what is next? Actually, that is what I think is really it's much more exciting, is that we're currently working on making those values updatable, right? So you don't need to re-index your entire code base, your entire document base when you have new PageRank values for something, right? With field cache, you basically have to re-index the document because it's turned into a term dictionary, and the term dictionary is currently not updatable. Currently, there's a lot of people asking for it for incremental field updates. I think I can promise it's not going to be in 4.0. And Grant is agreeing, so yeah, it's, incremental field updates is down the road, maybe something for 5.0. The updating is actually closer than it seems to. Updating DocValues is way easier than updating a term dictionary, right? So what we are doing here is actually we're writing a stacked version of the DocValues with a doc ID and value mapping, and when we're loading stuff into memory, you merge them together, right? Why we are doing this? Well, Lucene has a write once policy. So the most of the file, or actually there's no file, no segment file, or a file which belongs to the segment that is written twice, right? There's no modification. Once it's written, it's there. We don't modify it. If we merge, we write a new file. We copy all the bytes over. So you'll never get a corrupt index from a modification of a file. I know there's index corruption, so I'm not saying Lucene is completely free to index corruption. We do our very best to prevent this. Yeah, to be on the safe side, we're not rewriting files. Right, so the biggest problem here is that if you have a lot of DocValues, you have an optimized index, you want to update one file, one document, you basically have to rewrite the entire file again, right? Because your next reader wants to open it. This is what happens with norms. It's 1 byte per document. It's currently a specialized implementation, but we're going to cut this over to DocValues. So norms is going to be a specialized DocValues field. And deleted docs is the same problem, but with deleted docs, it's not that much of a deal because you only have like 1 bit per document, right? But when you update a norm array, what it does is once you write something to the norm array, it does a copy of the array in memory, and then it writes the entire memory onto disk once you flush it out. Nice part about it is that it's reflected immediately, right? So you change something and it's already there with your open reader. But if you open another reader on that segment, it won't be there. So there's a limitation if you use that feature. It's tricky. With DocValues, we'll implement a stacked approach. So you have your DocValues store, and once you update a certain document, we just stack them, right? And once we merge the doc stores together to 1 or more segments, we update those values, right? And the DocValues implementation is smart enough to actually represent the updated values in memory once you reload your DocValues. There's going to be a dedicated API for this on IndexWriter. So it's not fully fleshed out, but it's reasonably close. So what are the use cases for this? Well, my favorite example is the Android case, because we were not be able to do any custom scoring because of those limitations, and with DocValues it's actually possible, and it's also reasonably fast. You know, it's they have like good flash memory, but not necessarily super fast. For real-time search, it's very interesting because you get faster loading times, especially when you have frequently changing fields, when you use like click feedback or you use page ranks, all those kind of things. It's interesting. It's also for distributed search if you have things that need more than 1 round trip. It's interesting because you save a couple of seeks, even if you don't want to load it into memory. And Well, the most important use case is that is actually native. So there's no workaround anymore, no parsing of term dictionaries, less error prone, and stuff like that. All right, that's about it. Thank you for your attention, and we have 2 minutes left for questions. 5, great.
Hi, I'm obviously not understanding something because there was one chart where it went from 1,000 milliseconds to 90 milliseconds. It seemed like a significant increase, but then when you did the performance comparisons, you said it was all a wash. What explains that?
Oh, okay. I'm going back here. You're referring to those 2 slides?
Yeah.
So those are actually queries per second, right? So that's actually query execution time. This column here uses field cache. So it's basically an array lookup, right? This column here uses DocValues, so it's a method call plus some magic depending on the implementation behind that. And if you want to exchange field cache with DocValues, you probably want to make sure that it's not slower, right? And this slide only shows, okay, there's not a significant performance impact if you use that additional method call. This slide here is about loading things into memory, right? So this is before the array is actually existing, right? So since you have to un-invert the entire field, walk through all your terms, it takes much longer, and you also have to parse strings and bytes. And the DocValues, it's in the ideal case, it's simply like you allocate an array and say read, right? And then it's there.
Okay, so this is the loading time versus
right.
the. Thank you.
Right.
Hey, so what's the relationship to queries? So it looks like your query time is just fetching a field value, but what about if using it in a query? Is it always a function query? Or?
It's here. It actually it's using a function query. So those tasks here, those are the tasks we use for the nightly benchmarks, right? So it's the simplest case is the term query. It tries to discover based on certain properties, a term, and then it builds a term query and fires that term query. What I do here is I wrap it with a custom score query, and the custom score query is actually what is wrapping the function query, right? So the function, in Lucene land, it's called custom score query, but this is what's actually behind the function query. And it actually scores the term query, and then it takes a certain value in that field cache or DocValues to influence the score, right? And that, if you run it without the custom score query, you have like, on that setup, you have like 42, 45 queries per second. So there is an impact, but there's no big difference between those 2 implementations.
The same question on the performance. So you mentioned that for the DocValues, you can either keep it in the file cache or keep it in the RAM. So this chart, comparison chart, which one was it?
Those are all in memory.
All memory.
Yes.
And for the initialization of the DocValues, it's 100 times faster. And you said the saving primarily coming from the parsing and un-inverting. Can you just elaborate on that? Why it's 100 times faster than the field cache loading?
Okay, so let's go back to the float example I had in the beginning, right? So here, you index a field, and that field holds float values, right? So those float values are converted to a string or a bytes ref in Lucene 4, and they're indexed in sorted order, right? They're all unique. They're all pointing to the documents they occur in. When you load a field cache, right, you go to the term dictionary and position the pointer to the first term, get the documents iterator, iterate through the documents 1, 6, and fill the value 1.0 into 1 and 6, right? And so forth until you're done. You can have a lot of terms here, right? So it's like for each term, you look up the term, you parse it, that you know what you have to put in, you iterate all the documents, and so forth. For DocValues, this step is omitted, right? It's stored like an array. And what you do on load time is you just read that array in. So you prevent all these iteration through doc IDs and terms, and this is why it takes longer on the.
So you saved all the term docs and the seeking time.
Right, and it's also parsing, right? When you can run like simple benchmarks, parsing a float from a string is not a cheap operation, right? You also have to create those strings. Well, in Lucene 4, we prevent this. With the bytes array, with the bytes ref, but still to parse like float parse string, parse float takes a string, right? So you have to create those objects. They might be fast, they might be allocated in the stack, but still you have to create them. It's additional work.
Hi, so I'm wondering if, besides DocValues, were you thinking also about doing values for postings and for terms? Because I know for postings you have payload,
right.
It's not easily updatable, so it would be nice to be able to update it without inserting the document. But more importantly, I think it would be nice to have something like this for terms, that we could store a little value for a term and then just update it frequently.
One value per term. Yeah, there's a couple of workarounds you could do here with payloads again. But if you want to update payloads or if you want to update values per term, however it's implemented, it would require having incremental field updates. And that's the feature you have to wait for, unfortunately.
How long do I have to wait for it?
What was that?
How long do I have to wait for it?
I was actually waiting for that question. I was actually waiting for the question, when is Lucene 4 released? We're pushing on it. So my estimate is October, November, December. Yeah, wait a minute. And then you have to wait for Lucene 5. So it's probably 2025.
Okay, thank you.
Yeah. I got the end session, so thank you.